morning, students. Yesterday discussed the refraction through prism, a pure spectrum, impure spectrum, the differences between a pure spectrum and impure spectrum. Rainbow. Today in this class we discuss the formation of a rainbow. Rainbow is the best example for the impure spectrum. Formation of a rainbow. Usually, the sunlight interacts with the various kinds of matters in our nature, and we happen to see the brilliant colors of the feathers of the birds and the brilliant colors of butterflies. And oil spilled in the water appears to be colorful. The soap bubble appears colorful. Sometimes the edge of the clouds appear to glitter, and in a total solar eclipse, we notice the diamond ring. The diamond ring, the colors observed in soap bubble. These are all due to the interaction of light with the matter. So we enjoy the beautiful nature because of interaction of sunlight with the matter present in the nature. So in the formation of rainbow is also one such case, wherein light interacts with the water droplets present in the air medium, resulting in formation of rainbow. The necessary condition for the formation of a rainbow is sun must be in the nearby western horizon. During sunset, the sun will be near western horizon. Observer would see a rainbow opposite to the direction of the sun. That is, the observer would see the rainbow in the eastern region, provided if it rains in the eastern region. So, if it rains in the eastern region, the rain droplets take the shape of the prism due to gravitational force. The light from the sun enters into these droplets. Light enters into these droplets which have taken the shape of the prism. Thereby the light undergo refraction, total internal reflection, and again refraction, and observer could see a band of colors across the sky in the eastern region. The necessary condition is sun must be in the western and nearby western horizon, observer, and it must rain in the eastern region, and observer could happen to see a band of colors across the sky in the nearby eastern horizon. The necessary condition is the sun, the observer, and the center of the rainbow, all three must lie in a straight line. Microscopically, if you see a white light from the sun, as it enters into the droplets of the rain, the rain droplet takes the shape of the prism due to gravitational force. The white light breaks up into constituent colors. Violet bend most, red bend least. The refracted light traversing from denser water medium to rarer air medium, incidenting at an angle greater than critical angle for water. For water, the critical angle is 48 degree. If light incidents at these points at an angle greater than 48 degree, then light suffers total internal reflection. After total internal reflection, totally internally reflected rays once again incident on the interface of water medium and air medium. Thereby they undergo refraction. Violet light emerges at an angle 40 degree with the horizon, whereas red color emerges out of the droplet at an angle 42 degree with the horizon. So, formation of rainbow is due to dispersion of light, refraction of total interval reflection of light, and refraction of light. So clearly you can understand with this diagram formation of a primary rainbow. Here we have considered two water droplets. White light when it is white light from the sun. White light from the sun as it enters into these two droplets from upper region. So light enters, white light enters in the upper region of the water droplets. The light suffers dispersion. White light breaks up into constituent colors. Violet bend the most, red bend least. The normal drawn through the point of incidence passes through the center of the droplet. After dispersion, the light traversing from denser to rarer undergo total internal reflection. Total internal reflection. Violet emerges at an angle say 40 degree. Violet emerges at an angle 40 degree, whereas the red emerges at an angle 42 degrees. The red color as received by the observer forms an angle 42 degree with the horizon. Whereas in the second droplet, also the white light breaks up into 7 constituent colors. Violet bend most, red bend least. After dispersion, the light suffers total internal reflection. Violet emerges at an angle 40 degree with the horizon, whereas the red emerges at an angle 42 degree with the horizon. Observer standing on the earth happened to see a band of colors across the sky, and though the light reaches to the observer traversing like this, observer happened to see the light coming from this end. Observer happened to see the violet coming from this direction. So, observer receives violet color light from the droplet 2 at an angle 40 degree with horizon, and he receives red color light from droplet 1 at an angle 42 degree. The violet from the droplet 1 and lies above the observer, whereas red color from the droplet 2 lies below the observer. So observer would receive the violet light from the droplet 2 and red light from the droplet 1, and these colors appears to come from this direction. Observer happened to see a band of colors across the sky, what we call it as primary rainbow. So violet is at the inner side, outer side red is there. All remaining 5 colors fall in between violet and red. For convenience sake, here I have shown yellow color, and these colors, violet fades into indigo, indigo color fades into blue, blue fades into yellow, yellow fades into other colors. So here it is an impure spectrum. It is an impure spectrum. Since these color bands are not distinguished, they are not well separated, they overlap each other, one color fades into the other. Formation of secondary rainbow. Sometimes I personally have witnessed the primary rainbow as well as secondary rainbow. They will be formed one over the other. The description for the formation of secondary rainbow is like this. Again, we are considering the two droplets, 1 and 2. White light from the sun. White light from the sun. White white light from the sun enters into these two droplets from the lower side of the droplet. So here white light breaks up into 7 constituent colors, violet bend most, red bend least. Thereby the light suffers total internal reflection 1. Totally internally reflected light incidents on the water-air interface. Thereby the light once again undergo totally internal reflection, that is TIR2. Totally internally reflected rays traversing from water to air, denser to rarer, bends away from the normal. So here red emerges at an angle 53°, whereas with horizon, whereas the violet emerges at an angle 50° with the horizon. The same way in the second droplet also, first refraction, that is white light breaks up into 7 constituent colors. Refraction 1, refraction 1, here refraction 2, total internal reflection 1, total internal reflection 2, here refraction 1. Similarly here also two refractions, two total internal reflection takes place. The observer receives a violet light from the droplet 1 at an angle 53°, whereas red color light he receives at an angle 50° from the droplet 2, and these violet and red light appears to come from this direction. Observer happened to see a band of colors across the sky. Red lies in the innermost part, whereas the violet lies in the outermost region. Here also the colors overlap. The distinction between the primer rainbow and second rainbow is like this. Here in the primer rainbow, violet is in the innermost part, red is in the outermost part, whereas in the case of second rainbow, the red color falls in the innermost region and violet lies in the outermost region. Primer rainbow is 3-step process. Here refraction, total internal reflection and refraction. First refraction, then total internal reflection, then again refraction. It is a 3-step process, whereas in the case of formation of second rainbow, it is a 4-step process. First refraction, total internal reflection 1, total internal reflection 2, then refraction. It is a 4-step process. Being a 4-step process, there will be loss of some light. There will be a decrease in the intensity of light. Hence, the second rainbow is fainter than the primary rainbow. Primary rainbow is a bright one, whereas second rainbow is a fainter rainbow. It is not as bright as the primary rainbow. So these are the two major differences between primer rainbow and second rainbow. Here colors from inside to outside, violet and to red. Here the colors from inside to outside, red to violet. Colors are inverted in these primer rainbow and secondary rainbow. And the second rainbow is a fainter than primary rainbow, since it is a 4-step process, whereas for the formation of primary rainbow, the process is 3-step process. I hope you understand. It is not that easy to draw the diagram. You need to have the enough of practice. And another thing is, these are all the points. The light appears to reach the observer at an angle 40 degree. Then locus of all these points from where the violet light is received by the observer is an arc, not a straight line. It is an arc. That's why rainbow is always an arc shape, not a rectangular strip. Why the rainbow is always an arc shape, not as a rectangular strip? So observer receives a red color light at an angle 42 degree. So these are all the points. From all these points, observer receives red color light, and that red color light reaches to the observer at an angle 42 degree. Then locus of all these points, locus of all the points from where the red color is received by the observer is an arc. That's why rainbow is always arc shape, not a rectangular strip. So in the next class, we deal with optical instruments.